Hi all, this is Hani. Welcome back to our channel Code with Hani. Today we are going to solve September Basics LeetCode Challenge, which is minimum operations to make array elements 0. So it's a slighter extended version of a question which we solved yesterday, but the approaches are not connected, but the question looks similar. So there, yesterday questions we have a different condition. Today we have a different condition. So the approaches will be different. But here we have array of elements. There we have just two numbers. Okay. So you will be giving a 2D array that will have a queries where queries of I is of the form L comma R. So each queries of I defines an array of integer nums consisting of elements ranging from L to R, both inclusive. So if you see L comma R means so 2 comma 4. So in this it can be 2, 3, 4. That's what they are mentioning here. So in any one operation we can select two integers A and B from the array, and you have to replace them with floor of A by 4 and floor of B by 4. For example, here if you see 1 comma 2, only two numbers are there, right? In between there is no. So if you take 1 divided by 4 is 0, 2 divided by 0. Now the array of the full array becomes 0 comma 0, but here 2 and 3 comma 4. So what we have to do first, initially we have to take only two elements. So here what we will take, here they have taken 0, 2 and 4, which so 2 by 4 becomes 0, 4 by 4 becomes 1. So in the second operation 3 comma 1 they took. Now 3 by 4 becomes 0, 1 by 4 also becomes 0. So here the minimum operation is 1, here the minimum operation is 2. In total together it is 3. So what we have to do? Our task is to determine the minimum number of operations required to reduce all elements of the array to 0 for each query. Return the sum of the result for all the queries. So here if you would have taken at the first instance, for example, if you see in this example itself, if we would have taken first this 2, so 2 by 4, this 2 becomes 0. Now here it will be 4. So 4 again you would have done one more operation, it will become 1. So and next operation only it would have become 0. So if you taken this 2 first, then the minimum operation would have gone to 3, right? Now so we have to choose optimally so that we will reduce the number of the operations. So that's why here as per this our minimum operation is 2. If we would have taken this 2 first, then our minimum operation will go to 3. Got it? The same way. Yeah, here the query is 2 comma 6. So from 2, 3, 4, 5, 6 they have taken first num 0 and num 3. Yeah, like this they have taken, and the minimum operation required is 4. Got it? So now we have to figure out how, what all the things that we need to consider, or how we are going to approach this. For there is some set of things that we need to know before approaching to this question. Yeah, if you guys didn't get any idea, don't need to worry. I'll be explaining how clearly what all the things, how to consider this for this case, everything we will go through, and according to that, once we understand the core concept, then I'll be explaining the solution to you guys. Got it? So as we have seen the example, let's take this as an example, 2 comma 6. Okay, now if you see dividing any number, okay, for example let's take a number as I mentioned, dividing a number by 4, shifting it right by 2 digits in binary. So for example I have taken here 4. Okay, when you divide it by 4, our bit will go to here, so it is 1. So now if you see a pattern, 1, 2, 3 require one operation as their binary lengths are 1 and 2. So binary length is nothing but, so now if you take 1, 2, 3, 8, 4, 2, 1 will be assuming 0. So now if you take 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. So binary length is 1, binary length is 2, binary length is 2. So now to divide this by 4, okay, 3 by 4, 2 by 4, 1 by 4 will require how many operations? So this 3 will require only one operation to make it to 0, right? Yeah. So that's what I mentioned here. So 1 by 4 will give you 0. 0 in one operation. So when you divide at one time, it will give you 0, right? So that's what 1, 2, 3 require one operation as the binary lengths of 1 and 2. So binary length 3 and 4 starts from 4 till 15, which requires two operations from 3 and 4. Binary length from 16 to 65 requires three operations. Binary as their binary lengths are 5 and 6. Got it? So from this pattern, we got to know our binary length of a number x, for example 17, let's assume that's a x, which has a binary length might be 5, which requires by 2. Okay, x will require the binary length by 2 operations. So x by 2 operations. So x is nothing but here binary length. Okay, so binary length of a number x requires x by 2 operations. So 5 is a binary length of a number, it requires by 2, which is 3. Got it? So yeah, this how we'll be going. This is the things that you need to know. Basically we don't what we are going to do. So we'll be we want to know from 2 to 6 number of the operations. Now we know, if we know the binary lengths of 2, 3, 4, 5, 6, and their operations will be by 2, right? So if you cumulative sum of all this, you will get the number of operations for this 2 to 6. So how to determine 2 to 6? This is the L and this is the R. So if you figure it out, 1 to R binary sum of operations minus, so 1 to L minus 1 will give you, this difference will give us L comma R operations, right? So yeah, this is what we are going to find out all the binary lengths from the 1 to R, then 1 to L minus 1. Once we figure out which, we will subtract. Now we got to know the sum of the operations, right? So but sum of the operation, but if you pick one at a time, but our question they have stated you can pick two numbers, right? So whatever our result comes, if you do divided by 2, you will get the total sum of the operations. Got it? So yeah, I hope till this the concepts were clear. So what we are going to do, we know for this particular number of binary lengths, these numbers will have this binary length. So which will have the operation by divided by 2 of the given binary length. So once we got the binary length of each number, for example we need from L comma R, for example here 2 comma 6. So what we'll be calculating till 1 to 6, then we'll be calculating from 1 to L minus 1. So now if you minus this and this, you will get 2 to 6, whatever the operation number of operations, right? So that will be after, once you got the sum of the operation, will be dividing by 2, because in a question they state at a time you can take two numbers. So yeah, that's it. I hope this makes sense. Now I have explained how this works. So now we are going to take the same example, 2,6, it will range from 1 to 6. This is first, which is 1 to R. Now then we have to subtract 1 to L minus 1, right, which is 1 to 1. Then we will be getting 2 comma 6 number of operations. So if you see, initially we'll be taking our base as a 1. So as we mentioned, so for 8421, here the number is 6. Let's assume first we'll be passing num as a 6. Okay, once you pass, so let's assume we have a function called minimum operation, which we will get num. So once you get num, our binary lengths will start from 1 to whatever the num they are given. So binary length will be calculated from 1 and our base will be 1 and our initial count also will be 0. So now while base less than or equals to num, let's assume base is nothing but 1, 2, 4, 8. Okay, I is nothing but our binary length. Got it? Now first we will be counting for each binary length. How we will count number of, okay, from the given range 2 comma 6. Okay, how many number exist of the binary length 2, how many numbers exist of a binary length 1, how many numbers exist of a binary length 3, like this until your base is less than or equals to num. Why that condition I'll explain how that, why we have added that base less than or equals to num, because base is like our num, for example our num is 6. Okay, to the max it can have a binary length 3 and the base will lie 7. Okay, so when the basis goes beyond uh, 8, then we know okay after that that will not have any binary length. So yeah, for that we have added this condition. So the base should be less than or equals to r num. Got it? So what will, how we will be figuring out? Okay, so the count number of, so as we know our binary length 3 4 will have one operation, sorry, two operations, right? So basically x binary length x will have x by 2 operations, that what we have explained before, right? So what we will be doing, our I is the binary length here, so I plus 1 divided by 2, binary length divided by 2 will be the operation. Okay, 2. So now you figured out for the one operation you figured out, so that we will repeating for how many numbers have that number of operation. For example, here if you assume 3 numbers of the binary length 3, so we have to, we know the operation will be 2. 2 star 3 will give you the count of the binary, count of the number of operations of the binary length, right? So now we have figured out the binary length. This is number of operation for one binary length. Okay, so this is number of operation for one number. So now how many numbers exist, so that count will be, so our base finding out the count of the binary length whatever at that particular point. So r base minus 1 or your num. So this both minus base plus 1. So this will give you the number of count of the binary length. Okay, for example, let's assume we have a binary numbers 1, 2, 3, 4. Now our I is 3. Got it? Let's assume our I is 3. Our base will, if when I is equals to 3, our base equals to 4. Got it? So now till this point you would have already appended the count. So for base for binary length 3 or 4, what will be our number of operations will be 2. Star min of, here our base is 4 star 2 minus 1 is 8 minus 1 7. So till 7 you will have the binary length 3. So here, okay. Till 7 you will have the binary length 3, but our num is till 6 only. So this is additional count, right? So because our num is 6 but our base is 7. So in that case only we are using min of base 2 minus 1 comma num. So in this case R will be 6 minus 4 plus 1. So why you are doing 4 minus 4? For this base, after this base only our binary length 3 would have started. From 4 only our binary length 3 would have started, right? Before that, whatever it is, that is of binary length 2. That count you should not take it for the binary length 3. So that's why we are subtracting the previous base number. Okay, 4 plus 1 will give you 6 minus 4 plus 1 will give us 3, right? So now if you see from 4 5 6, these are the three numbers of binary length. So 2 3s are, which will contribute 6 operations. This will take to make these numbers 0. Got it? So yeah, I hope this formula you guys would have understood how this, why the min of base minus base star 2 minus 1, base multiplied by 2 minus 1 and num works, and why we are subtracting the base plus 1. This is basically the count of nums in binary length. This is number of operations. Got it? Once you find out the count, now you will be increasing your binary length. I plus 1 equals to 2. 1 and our base will go to next multiply by 2. This is our base now. Every base will be multiplied by 2 of the next. So now we have to find out the binary length of 4 with the base 8. Got it? So yeah, this is the basic approach to get the all. If you pass 1 to from 1 to R, if you pass numbers as 6 till num 6, how many binary lengths exist, and count of those will give you the num minimum operation. Cumulative of that we will be returning count. First you will be figuring out the R, then we will be figuring out L minus 1. Then if you subtract both, you will get the total number of operations. So once you figure out the total number of operations, and what we will be doing, we will be dividing that by 2 to get, because at any point we'll be picking up two numbers, right? So now we'll have the original function here will be original main operation in queries. What we will be doing will be, so our result initially equals to 0. Now result plus r equals to, you will be calling query will have two params, right? 0 and 1. So which is 2 comma 6. We'll be passing first self dot min operations of, first you will be passing r, which is query of 1, that we will be subtracting with self dot minimum operation query of 0 minus 1, which is L minus 1. So once you get this difference which we will be dividing by 2, because this min operation considers only one at a time. So but our question, they said we can pick any two numbers at a time. So yeah, by dividing it by 2, and we are returning the result at the end. I hope you guys would have understood. Okay, basically the concept is very simple. We know the pattern. So if the binary length of 3 or 4, if it is 1 or 2, operation will be 1. If it is 2, 3 or 4, operation will be 2. So by then we know, okay, what are the binary lengths that fall. We are figuring out the count of the nums that falls in the binary length by this formula. One, so now the corresponding binary length, and you're figuring out the count. If you do multiply, so we'll be getting the minimum number of operations for those nums. Then we'll be increasing our base, increasing our binary length to figure it out until the base is less than or equals to the num. Once it is exit, there is no need of calculating further, because our till our right hand side or left hand side, whatever the num we are passing, till that point only we need to figure out the minimum number of operations. So here I have written, so when num equals to 6, when I equals to 1 and base equals to 1, initial stage we have passed num as a 6. Okay, count equals to 0. Got it. Now if you see I plus, so for I equals to 1, binary length 1 or 2, our minimum number of operation will be 1. So here if you see, for 1, for the base 1 we will have only one element, right? So that's what we are, your base minus 1 comma num, this is the smallest. So base star 2 minus 1 will give you the number of elements in that particular base. Why we have checking min of that base number of elements comma num, because sometimes at the termination condition the base, for example here the binary length 3 has 4 elements but our num goes till 6. So in that case we have to pick only till 6. So that's why we are adding this minimum condition here. So basically this base multiply by 2 minus 1 will give the number of elements. Okay, then why you are subtracting the base from it, so that we'll ignore the previously calculated base. Previously how many number of elements will be here? Here will be, if the base is 1 it will be 0. If the base is 2 it will be already, you might have calculated the 1 element. If the base is 4 you might have calculated already, you might have already calculated 4 elements. Yeah, like that. From 4 only the binary length will start. So that's why we are subtracting the previously calculated. Yeah, when num equals to 6, I equals to 2. Now the I is nothing but binary length and our base will be now 2. Now for 2 we have only 2 elements, which is 2 and 3, right? So if you see, now we got the 2 elements and the minimum operation is 1. So 1 star 2 is 2, already 1 plus 2 will give us the count 3. Now for I equals to binary length 3 and 4, we know the as per the pattern we will get the operation 2. So yeah, 3 plus 1 divided by 2 will also give you 2, and 4 divided by 4 plus 1 divided by 2 will also give you 2. So yeah, here mean 7 comma 6, because here our base total number of elements was 7, but our num goes till 6, so we'll be taking 6 and we are subtracting the previously calculated elements, which is 3. 4 minus 1 will give you 3. By then we know number of elements of the binary length 3, which will get added. It is 3, so each will take 2 operations, so 2 star 3 will give you 6. In total it is 9. Yeah, this is the approach we used to solve the question. So I hope you guys would have clearly understood why we are using this formula and why we are multiplying by 2, why every time we are increasing the binary length. I have given enough explanation for everything. If you still didn't understand anything or if you have any questions, please do leave a comment in the feedback. I'm happy to help. So here the time complexity will be to the max. It can be whatever the r comes, okay, that could be the maximum. It can go for the minimum operation, right? Also, if you see, we are increasing the base every time by 2. It's not like we are running 6 times the loop. So if it is 6, we have run only 3 times. So as the base is exponentially increasing, right? So we'll be taking this as a log r, and for each query we'll take n. So for each n to the max, it will go for log or times. Got it? Yeah. And our space complexity will be order of 1 because we are not storing other than just we are using the variables count, base, and binary length or something. Yeah. I'll be providing the GitHub links to the solutions in the description. Please go check it out. If you still don't understand, try to debug it on your own for better clarity. Yeah. If you like my video, please do like, share, and subscribe. Yeah. Thanks for watching.